In this section, we're going to be looking at the 5% guideline for multiplication rules with probability. Now, this is a particularly useful rule when we're looking at doing multiple events. So far, we've looked at anywhere from 3 to 5 events. We haven't gotten any larger than that. However, this is not always the size of the events that you are sampling. So we're going to look at the problem exercise number 28 on page 167. And here we can see that we're going to be looking at 40 separate events. We're doing 40 samplings out of this population of 1,027 adults. So the problem we are given here is we want to know the probability that each of these individuals chooses some form of flirting besides email. So in the description above this, we're told that 61 individuals out of this 1,027 person sample said they preferred to flirt via email. So we're looking for the odds that if we selected 40 people out from this 1,027, that all of them would choose some form of flirting besides email. Now, this is sampling without replacement, which would mean it is a dependent probability problem. So, from the approach we've looked at so far, we would have to do 40 different probability formula, adjusting each one for the preceding event. And that would indeed take a very long time. Perhaps not forever, but it might feel like it by the time you're done with it. However, there's an additional step we can add in to our multiplication of probability decision flowchart that lets us get a faster solution. Here, you can see I've added in to the flowchart an additional step where if A and B are dependent, then the next question we ask is the sample size 5% or less of the overall population? If the answer to that is yes, then we can actually use the multiplication rule for if they are independent events. So the idea here is the fact that the population size is sufficiently large and the sample size is sufficiently small that we can work with the easier rule of multiplication if treating them as if they were independent events. So, does this apply to our problem? Yes or no? Well, if we take our 40, which is how many of our events that we're doing, divide it by 1,027, so remember 40 is the number of ways that we're looking at here, and we divide it by 1,027, we get 0.039. So this tells us how large our sample size of 40, what percentage it is of the overall population of 1,027. And in fact, we can see that at 0.039, this is less than 0.05, which is a decimal point version of 5%. So yes, we do get to use our 5% guideline rule. So let's look at what this, how this sets up as we go through it. So here we're using, again, we've got our basic probability formula, but notice we've added the exponential of 40. That is because we have 40 times, we're taking 40 samples, right? So we're removing 40 individuals from this overall population. So we're going to calculate out the probability for a single event of removing an individual from that population. Then we're going to use that by the exponential of 40 because it's the total number of events we've got. So as you can see further down, I've tried to write this out for you in more general language just to kind of help you connect multiplication that we're doing, the formula layout, with the description above. So what we're really looking at here is the number of ways we can select a person who chooses some form of flirting besides email divided by the total number of people surveyed, and then the exponential of 40. So, to get to the number of ways we can select a person who chooses some form of flirting besides email, if we have 61 of the people who chooses flirting via email, then taking that original 1021 and subtracting 61 from it will equal how many individuals chose something other than email. So that gives us 960 divided by our 1021, which gives us 0.9402545, the exponential of 40, which with our rounding rule gives us 0.0851. So, when you're looking at a problem, one of the steps you need to solve as you go through and back and look at that flow chart is if you are looking at dependent events such as sampling without replacement, but the sample size is 5% or less than the overall population, you can still go back and use the multiplication rule probability treating the events as if they were in fact independent.